you.
How was your weekend, Mr. Bell?
Great, thank you. Okay, we're going to go over the test that you took on Friday. When I call your name, please come up and get your test. Keep it at your desk. Remember, if you made below a 70, I expect you to come take it starting tomorrow. You will have till Friday to take it, and I will go over the correct answers. Lane, here. Matthew.
Are they graded new or no?
Huh? They're not there yet, no. Freddie. Come up quickly, please. Got lots of things to do today. Raphael's not here. Dylan's not here. Farah. Araceli. Chris, little Chris. (205-713). Angela, excuse me. 205-713. Gracie. Annika. Madeline. Terry. Jacob. 206-831. Sterling. Daniel. Catalina. Dahlia. Dalton. Ren.
Thank you.
Yep. Alexis. Gerardo. Big Chris. Anybody in here did not get theirs back? Jace, you'll need to go sit in the hall. Close the door behind you, please. I'll need to see you tomorrow morning to take your test. Okay, let's go over the test quickly. I'm going to go over the correct answers. You check your answers. I'll mark them if they were wrong. So just go, as we go through, just mark the correct answer. Number 1, what is the large number in front? That is A, coefficient. How many elements are in the chemical formula above? MgNO, that's 3G. Number 3, how many atoms of magnesium? Well, magnesium, you have to put a 1 here, and then 4 times 1 is 4, so that was C. That is trash, yes, the recycling component. Number 4, how many total atoms? We have to get rid of the parentheses. 2 times 1 is 2, and 2 times 3 is 6. And then we have to go 4 times 1 is 4, 4 times 2 is 8, 4 times 6 is 24. When you add that all together, you get J, 36. So 4 is 36. Number 5, what is the small number below the O called? And that's B, a subscript. Number 6, a chemical change is main difference from a physical change. Remember, when you hear the word chemical change, you should think new substance, and that was F. Number 7, if a chemist mixes 2 liquids in a solid forms, it's called a precipitate, D. Precipitate. On the back, the only thing that we studied was the law of conservation of mass. And you can see that the masses there are equal. 300.23, they're equal. I don't understand why some of you missed this. We've never talked about the law of conservation of reactants or the conservation of products or the conservation of energy. Okay, using this chemical equation, answer the next 4 questions. Identify the reactants. Well, the reactants are right here. So it was A. Identify the products. The products are here. They don't have to be in the same order. There is salt and water. It was F. Salt and water. They just happen to be out of order. Who cares? You're still getting those 2 chemicals. Number 11, what happens to the atomic bonds? The bonds break. We've talked about that over and over. Number 12, observe the chemical equation above. What is the coefficient of the water molecule? Well, here's the water molecule. It's not a number in front of it, so you assume it to be 1, G. Okay. On number 13, the above chemical equation balanced or not? Well, there's 1 Si, 1 Si, 2 oxygen, 2 oxygen, 2 carbon, 2 carbon. It is balanced, A. 14, what is a new substance produced during a chemical reaction called? It's called the product. Number 15, Ava toasts a marshmallow over fire. Which of these is not evidence? Remember, city girls like their phones. The interior melts. That's not one of those, so it was A. Turning black is changing color. New substance is chemical. Giving off an odor is sometimes. Now, we didn't talk about that one, but melting we did talk about it. Melting is physical. Number 16, which of the following is an example of a chemical change? Dissolving isn't, tearing isn't, melting isn't. That's the only one we talked about. It was J, interesting. Number 17, which of the following is not an indicator of chemical reaction? Again, country girls like their phones. Production of gas is, precipitate is, change in temperature is. It was C, dissolving. The sample of a liquid is cooled from 23 to 0, causing the liquid to freeze. Freezing is a physical change. J. Number 17, the law of conservation of mass states that mass cannot be created or destroyed. C. Too many people miss that. You need to restudy that if you can't remember that. Okay. Number 20, which compound below could be classified as organic? Well, we need carbon and hydrogen. It was F. F. And I don't know why the little machine is going so slow here. 21, what are the starting substances in a chemical reaction called? And those are the reactants, D. Next page. Above is a model of a chemical compound. What is the chemical formula for this compound? Where we have 1 C and 2 oxygen, so we know it's 2 CO2. And that would have been J. 23, according to the law of conservation of mass, the mass of the reactants in chemical reaction have equal mass to the product, B. They're equal. Okay. Number 24, that's my machine over there. We'll stop in a minute. Is the above chemical equation balanced or not? Well, we have to start counting. There's 2 iron, 2 iron, 2 hydrogen, 2 hydrogen. There's 1 sulfur here, 3 times 1, 3 there, so it was F, unbalanced. It was unbalanced. 25, palladium is a hard, lustrous, and malleable. Lustrous and malleable are your clue words there. So that means it's a what? Metal, A. 26.
Teachers, pardon this interruption, but it is now time for any 7th grade student that needs to do a picture retake.
On this one, again, we had to try to balance it. Okay, how many? There's 1 Z in here and 1 here, so that's balanced. There is 1 sulfur here, 1 sulfur here. There are 3 oxygen on this side. Now, the easiest thing to do is just start plugging these in. So, taking F, put 1, 3, 1, 1, and see if that does anything. That makes 6 oxygen, but there's still just 3 here, so that one didn't work. Then try 2, 3, 2, 2. 2 times 1 is 2, and 2 times 2 is 4. That's 6 and 6. Okay, I think that was the correct answer. G? Is that what is marked on y'all's paper? Okay. It was G. Okay, on this one, 27, the most important characteristic here is this one. If elements are gases, what are they? They're nonmetals. B. Too many people miss that. All of the noble gases are nonmetals. 28, which of the following comparisons correctly describes subatomic particles? Electron is negative, larger than the proton? No. Neutron is negative? No. Neutron is neutral and a mass larger than the... That is it. H. That's just thrown on there to see if you're remembering the stuff from the previous units. And that will always happen on my test. They're cumulative. Okay? Best below are 4 ball and stick models representing compounds. Which of these best represents ammonia? We have an N with 3 hydrogens. So how many atoms do we need? 4. We need 4. This one has 5. This one has 4. This one has 3. And this one has 2. So it was B. Okay, we needed 4. Okay, density. Density is mass over volume. We have 90 over 4. 90 divided by 4. So it's 22 something. When we look, there's only one of them with 22, so it was J. Okay, on this one, again, this is equal. 192 plus 64 is 256. So we need these to be 256 over here to be equal. Now there's 2 ways of doing this. You could take each one and add them to 152 and find it. And that would have been it right there. Or you could have taken the 256 and subtracted the 152. 104. Okay. 32, an element dull and brittle. What is it? If it's dull and brittle, is it a metal, non-metal, or metalloid?
Metalloid.
Dull and brittle is non-metal. So it's 4, so it was J. Dull and brittle. If an element has 1 electron in its valence shell, you already should know it's right here, 1A. So it was in 1. Any questions? Okay, if you're happy with your grade, you don't want to take it home and show your parents, you can bring it up and put it in the recycling bin right here. Those of you who have to retest need to take it and study.
Mr. Klomp,
Yes, ma'am?
do you have Dahlia Garcia?
I do.
Could she come to the office for a moment, please? Thank
Yes.
you.
Okay, we are going to begin. This is trash, that's just like. Okay, we're going to begin Unit 5. Unit 5 is about force and motion. This is called the science of physics. So we're going to be looking at that stuff over the next couple of weeks. Force and motion. We're talking about all sorts of motion of objects and how objects move. Okay, this week, today we are going to be talking about differentiating, telling the difference between speed, velocity, and acceleration. We are also going to relearn from 6th grade, or we're going to review from 6th grade how to calculate speed and velocity.
Excuse pardon this interruption, but now I need any 8th grade students or staff that needs to have a picture retake or a picture taken report to the cafeteria.
Okay, on Tuesday, we're going to be looking at graphing motion. On Wednesday, we'll look at analyzing motion graphs. On Thursday, we'll talk about balanced and unbalanced forces. And on Friday, we will conduct a lab where we're looking at balanced and unbalanced forces. On Monday next week, we'll do part 2 of that lab. Okay. To begin with, though, we're going to get our unit organizer. Please take out your science journal, your composition book. turn to page 28. Please glue this down to page 28.
Are we in our board?
You don't need Okay, the unit organizer, let's go over it real quickly. First of all, after you glue that down, please copy that into your table of contents. Today we'll be adding force and motion, unit organizer, and we'll be talking about Unit 5 vocabulary, and then we'll do a little activity with speed, velocity, and acceleration. It's your job today, everybody listen, to learn the difference between speed, velocity, and acceleration. Does everybody understand what you'll be learning today? Before you leave this class, you'll need to know the difference between speed, velocity, and acceleration. Okay, speed, velocity, and acceleration. I'm also going to be passing out the vocabulary. We will talk about the clue words to help you memorize the vocabulary. This can be moved down to page 29. Okay, force and motion unit organizer, page 28, unit 5 vocabulary, page 29. Yes. Gracie? Dalton? You gotta show me. That's
I got some red on my shirt.
You have to have red on, you have to have tried. Dress up red, blue, and pink.
See?
No, we just put the pen in the box.
You gotta take your jacket off. Okay, put your name on there, please. Okay, let's take a look at the, just lay those on your desk. I'll come around and pick them up in a minute. Let's take a look at the unit organizer real quick. This is what we will be looking at this unit. Log in and start from the website. And you can start these courses. It's right a little started off. Where you get the parties.
Got it. I know it's your
Yep.
What to do with the one we were starting with?
Y'all look around the hall.
I think it's like.
Did you get all that stuff? There's more, grab it more.
No,
That you won't be able to do, but you can take it.
And Fridays,
Okay, let's go over this. We'll go over it in a minute.
Tomorrow.
Okay, differentiating. Today we are going to be looking at differentiating speed, velocity, and acceleration. So force and motion is about understanding the difference between these. So this is what we're doing today. We will also be doing this today. You need to be able to calculate speed using the formula speed equals distance divided by time. And we will look at the solving triangle again and learn a new solving triangle. We'll also be looking at graphing changes in motion, and we'll start that tomorrow, where we're looking at graphing changes in motion. And then on Friday, we're going to be looking at balanced and unbalanced forces, and that's what we'll be looking at next week, balanced and unbalanced forces. So this part here you have already learned in 6th grade. We're not going to spend a lot of time relearning this. You will do some problems calculating speed. We'll also add calculating velocity. Velocity and speed are very similar, okay? But the main thing you need to know is this and this, okay? The difference between balanced and unbalanced forces. Any questions about that? Okay, grab your highlighter for your vocabulary. Here are the clue words. Okay. Speed. Vocabulary quiz will be one day next week. Speed. Please highlight rate, objects, cover, distance. Rate, objects, cover, distances. You know, when you're in your car and you look at the speedometer, what are you measuring? The speed. It's called the speedometer. Okay, average speed. Distance traveled divided by time. Distance traveled divided by time. Now, if we drive from here to Houston, we don't drive the same speed all the time, do we? We might have to slow down because of traffic. We might get the speed up. So there's lots of changes in speed. But we could set our clock, our timer in Columbus, take off, and travel to 75 miles to Houston, and then divide that by the hour it took to get our average speed, and that's what that means. It's not all the slowing down and speeding up in between, it's just the average time it took. Okay, velocity, it's speed and direction. Speed and direction. All velocity has a direction with it. So if we were going to Houston, it would be, we were traveling 75 miles per hour east. Everybody understand? It has to have that direction, east. Or it's going to have south or north or some direction. Acceleration, it's a rate of change in its velocity or speed. The rate of change. So for example, if we're going 50 miles per hour and we suddenly have to step on the gas and go 80 miles per hour, what did we do? We accelerated. We accelerated. It's a change in speed or velocity. What if we're going 80 miles per hour and somebody in front of us stops and we have to slam on our brakes and go from 80 to 50? Did we accelerate?
Nope.
Yes, we did. We accelerated. Acceleration is any change in speed. In physics, there is positive acceleration and negative acceleration. Now, we slowed down, but that was a negative acceleration. Negative acceleration. Okay, motion is a change in position. Any change in position. A force is a push or a pull. Balanced forces, forces that are opposite in direction and equal. Opposite and equal. Forces that are opposite and equal. Let's say you were doing tug of war. You had two teams, and the rope never moves. Are those forces balanced or unbalanced? They are balanced. That's all that means. Equal forces pulling in the opposite direction. Unbalanced forces. Any unbalanced force causes a change in motion. So if I come over here and hit this blue bottle and he goes flying, is that balanced or unbalanced?
Unbalanced.
It's unbalanced. That simple. It's that simple. Okay? Net force. Net force is the overall force acting on an object. We could have 6 people pulling on a box. We might have to add and subtract those forces to get the net force on the box. If the people are pulling in the opposite direction, would we add them or subtract them? We would subtract them. If the people were all pulling in the same direction, what would we do to the forces? We would add them. That's just common sense. Okay? Friction is a resistant force. Resistant force. Newton is the SI unit of force. So when we measure forces, they are measured in newtons. And we will look at that later. Weight. Weight is the force of attraction between two objects. The force of attraction between two objects. All objects have gravity, including you. Including this pencil. Including these dust particles on my shirt. Everything has gravity, that has mass has gravity. Now, the reason why the Earth is able to hold things toward it is because it is so massive, it's so big. Now, you are pulling on the Earth. But because you're so small, do you apply much gravity to the Earth? No. But you do still have gravity. Okay? Everything with mass has gravity. Any questions about these? Okay. Let's move on. Everybody get all those? Again, be studying those words. You'll have a quiz one day next week. We are going to take a look at a little activity we're going to do. We went over those two. Okay, let me give you your sheet for this, and then we're going to do this little mind game here. This will be glued down to the next page. You might want to wait until we do it before you glue it down. Stop. Okay, I want everybody to think about this scenario. 2 students. And then on your sheet, you can, first of all, on your sheet, it's all here. It's written here for you. 2 students, Darian and Tron, are running in a 100-meter dash. It took Tron 10 seconds to run 50 meters, while Darian ran it in 12 seconds. Okay? We're running 50-meter dash. Tron, 10 seconds. Darian, 12. Can somebody tell me, given that information, which student is running slower? Don't say it out loud. I want you to write something on this sheet with you and your partners at your table. I want you to answer those 2 questions on your... Okay, it's on the front. Try to answer those 2 questions. Be able to explain your answer. You can talk to your neighbors at your table if you need to. If you got one of your things, your hand. No. Help That's close enough to red, I guess. Okay. Tell me. Okay, Chris, which student is running slower?
Dario?
Explain it.
Well, he's running slower because it took him more time to finish the race.
That's exactly right. Okay. So, the speed of Darion is related to what? To time. His speed is related to the time it took.
The more time it takes, let's say it's got to be.
Exactly. And the more time it takes, that means the slower you are. Okay, so you have to be thinking about time in that way when we're talking about speed. Okay? Little Chris, which student will probably win the race? Who? Tron or Darian? Tron, why? Use the data there. Why do you think he will win? Think about the time. Exactly. So it only took him 10 seconds.
Less time it takes to change the game.
Exactly. Now, is it guaranteed that Darian will win? No. What's something that could happen?
He could fall.
He could fall. He could get tired and slow down. Tron could speed up. Tron could end up winning the race. All you would have to do is kick it in a little bit more and speed up. Okay. So, could Tron win?
Yeah.
Yeah, he could. But his speed will not be able to stay the same. He would have to speed up. Well, we don't know who's going to win. But given the data we have, with Darian running, well, this is going to be a 100-meter dash, and at 50 meters, Darian is running it in 10 seconds. Tron is running it in 10 seconds, and Darian is running it in 12. We have to assume that Tron is probably going to win because he's going faster. But remember, things could happen. Tron may trip and fall. He may get tired and slow down. Darian could speed up. All of those things could happen. But given the data we have to assume that Tron's going to win. Okay? We have to assume he's going to win. Any questions about that? Okay, let's take a look at what these are. So flip your sheet over, please, and you're going to be writing the definition for each one of these words. First of all, what is speed? The distance an object travels in a certain amount of time. As you are writing that down, be saying it to yourself. The distance an object travels in a certain amount of time. The distance an object travels in a certain amount of time. Okay, and then we're going to look at an example, and I do want you to write the example down. Okay, the distance an object travels, Lane, pick your pencil and write. The distance an object travels in a certain amount of time. You'll see that again. Okay. First of all, the only thing I want you to write here is this example. Right here.
For speed?
Yeah. Below speed. A football field is about 100 meters long. If it takes a person 20 seconds to run its length, how fast was the football player running? Could you please write that example down? It won't take you but a second or two to do it. Okay. A football field is about 100 meters long. It takes a person 20 seconds to run its length. How fast was the football player running? Then draw this solving triangle. Right, use pencil less to move on your paper. Okay, now we're going to solve this problem by using this solving triangle. Speed is equal to distance over time. And this is the reason why this triangle is set up like this. Remember, distance over time, what would you do to these two numbers to solve for speed? You would divide. If we were solving for distance, what would you do to these two numbers? Multiply. So remember how to do that. Now in this problem, what is the distance?
100 meters.
100 meters. So where the D is, we would put 100 meters. And the time would be
20 seconds.
20 seconds. When we divide those, we get 5 meters per second.
So he's running.
5 meters per second. Which is 100 meters in 20 seconds. That's pretty fast. Well, relatively. You write the example, draw the solving triangle.
And we don't know if he's running his football pads or not.
No, we don't. He might be quicker. 100 meters in 20 seconds. You know, somebody in the Olympics would probably run it in 8, 9, right?
No, Tyree can run his in like 13 too.
Yeah, so this might be a little slow. But it's pretty fast for normal people.
The logic speed.
Okay. Any questions about how to solve speed? Okay, let's take a look at velocity. Everybody have all that? Okay, a couple more minutes. Okay. What is velocity? An object's speed and direction. Speed and direction at a given time. Definition, velocity, an object's speed, Dalton, and speed and direction at a given time. Okay, let's look at an example. A car traveled 200 miles north in 2.5 hours. What was the car's velocity? Now this problem looks very similar to the one for speed. A car traveled 200 miles north in 2.5 hours. What was the car's velocity? Now, if you look at the solving triangle, the only thing that changed is the S changed to a V. Velocity and speed are calculated the exact same way. The only difference is your answer must have a direction with it. The answer must have a direction with it. So we are looking for the velocity here, so V will be there. What is the distance?
200 miles.
200 miles. And what is the time?
2.5 hours.
2.5 hours. If we solve that, we get 80 miles per hour. Now, look at the answer there. What is included in that answer that's not included in speed? North. Anytime you solve for velocity, you must include a direction. North, south, east, west. Up, down, some direction.
What about northeast, southeast?
Exactly. Some direction. Okay. Again, please draw the solving triangles if you haven't done so on your sheet. Draw the solving triangles so you remember how to do it. These are the notes you will need to do your homework tonight. Okay? Questions about velocity? So, Farrah, what does velocity include that speed doesn't? Nope.
Direction.
A direction. So, Sterling, what does velocity include that speed doesn't? What does velocity include that speed doesn't? Look right here. Direction. Jacob, what does velocity include that speed doesn't? A direction. Jace, what does velocity include that speed doesn't? A direction. Alexis, what does velocity include that speed doesn't? Thank you. Okay, let's move on to acceleration. Let me get my mouse down. Okay, acceleration. It's a change in the direction or speed of an object over time. A change in direction or speed of an object over time. let's say I'm going 1 meter per second this way, and I turn and I'm continuing to go 1 meter per second this way. Did I accelerate? Yes, I did, because I changed direction. Okay, I changed direction, so I accelerated. A change in direction or speed of an object over time. Okay, let's look at an example. You don't have to calculate acceleration, but you need to know these things. Acceleration is either a change in speed. Yes. A change in speed, either starting, stopping, speeding up, or slowing down. Or a change in direction. Now, using those notes, you need to sort these cards into 3 categories. One of these cards either represents speed, velocity, or acceleration. Find the little card that says speed, the little card that says acceleration, and the little card that says velocity. You can put that away, but you might need the notes to do this. And then put these into the right order. You and your table will work on these together. When you think you have them, call me over and I will check to see if you are correct. Y'all may have to stand up and move around where you can see all the cards.
Is there speed, velocity, and
Acceleration, yeah, find those little cards. Yes. Make sure you glue that note sheet down. Yep. Anything starting or stopping is acceleration. Look at your notes if you need to. That was on a no. Yes. Or something that's changing direction.
that's kind of what
That's right. That's right.
Oh, I didn't. Fred,
Do that now.
take a look at it. See my other acceleration. For speed, it's going to show you how fast you're going. It's going to give you an hour, minute, second. Velocity is going to give you how many miles, how fast you're going. And then give you direction.
First has to have a direction.
North, south, west, northwest, and acceleration. It's going to tell you, you're slowing down. Let's go. Understand? You got it? Yeah.
Okay, remember. Yeah. Is it changing direction? Okay, if y'all are finished, call me over and I'll check it. Make sure you all come around and look at this. Constant speed. What was it?
Teachers, pardon this interruption, but this is one last call for any teacher or students that needs a retake or did not have their picture taken last time, they need to report to the cafeteria this
Yeah,
time.
this is in Canada. Back. Y'all understand all that? Put it back in the Ziploc bag and put it on my desk. Zip them up and put them on my desk. Yeah, I think I told one of them. Store the house so that we block it. Okay, these are all the directions. Store the house. Store the summit. Canada. Northwest. North direction. This is coming to a stop. He's coming to a stop. This is toward her. Right, it's changing direction. Changing direction. Look at this. This is action. Go put the cards on my desk. Okay, call me when you're done. Grab your homework, yes. I laid it on the table.
Alright, now. Adults and nappies.
Tell them that they need to come by and get their homework. They left it laying on the table. I don't accept late homework.